Hi, so today we're going to be covering chapter 4.4, which is zeros of a quadratic function. Now, there's a lot to cover in this one. It's going to look intimidating at first, but soon you'll understand. So, I have quite a few examples here, just to get an idea. And it starts with simplify. Express your answer in radical form. Do not use a decimal with 180. And the reason why it's starting with something like this is because we're going to be doing simplification of radicals quite a bit in this unit. So we're going to take 180 and we're going to prime factor it. So 180, 2 and 90, 2 and 45, 5 and 9, and then 3 and 3. Whoops. So now you look at the index. If there's nothing in that slot, like there is in this problem, then the index is a 2. It's implied 2. If it was a 3, we'd be doing about the same thing, but we'd be looking for pairs of 3 instead of pairs of 2. So we're going to look for pairs of 2 since the index is 2. So here's 2 2s, here's 2 3s, and we only have 1 5. So we can take out a 3 and we can take out a 2, and we'll multiply them when we take them out. So 6 times, and then whatever is left over on the inside, which is 5 in this case. So this would be your answer. Same for this. We'll do 250. We're going to split this. This is going to be 50 and 5. And that's going to be 5 and 10, which is going to be 5 and 2. So we've got 2 5s, and then we have a leftover 5 and 2. So we can take out a 5. So 5 square root of 2 times 5. So 10. That would be your answer. You multiply what's inside and you multiply what's outside. Simplify. Express your answer in radical form. Do not use a decimal. So 45, square root of 45, that's 5 and 9, which is 3 and 3. So we can take out a 3. So we have 3 and 5. 3 times the square root of 5. Solve for x. So now we're going to be getting into finding the zeros. When it says something like solve for x, we're going to be expressing our answers as just like x equals 1 or x equals 3, something like that. We want to separate each item in our list with a comma and express it in radical form if it needs it. So this one has done it a lot for us already. What we can do is x minus 4 squared equals 15. And what can we do to get x by itself? 15 is already on this side, so that's good. We always want to get the furthest thing away from x. So here's a square. So we can't do anything until we square root this. That will get rid of it. So here's a square root here and a square root here. And this second will cancel out, and you'll be left with x minus 4 equals, and now it's going to be plus or minus the square root of 15. It might just be plus. No, it should be plus or minus. So now what we're going to do is we're going to add 4 to both sides to get x by itself. And that leaves us with x is equal to 4 plus or minus the square root of 15. This cannot be simplified anymore. We just get a 5 and a 3. So 4 plus 15, square root of 15, comma 4 minus the square root of 15. Now we want to solve for n. It's going to be the exact same process. I'm just going to do quite a few examples so you get it. So this one, we're going to square root both sides. So now we have n plus 1 is equal to the square root of 48. 48 is the same as 8 and 6, which is the same as 2 and 3 and 2 and 2 and 2. So we've got 2 pairs of 2 with a leftover 3. Let me move this down a bit. Is equal to something plus or minus 2 times 2, which is 4, with a leftover of 3 on the inside. We can minus 1 from both sides, and that will give you your answer. So n is equal to negative 1 plus or minus 4 times the square root of 3. And you would separate these answers. So negative 1 plus 4 times the square root of 3, and negative 1 minus 4 times the square root of 3. Determine the zeros of g of x equals 5x minus 2 squared minus 320. So what we can do is we want to get everything that we can to the other side. So we're going to plus 320 to the other side. So we have 320 is equal, well, first and foremost, you set the whole equation equal to 0. You get rid of your g of x, which is fine. So now we have 5x minus 2 squared, and then we can divide both sides by 5. Hold on. And this should give you 325, 32, 6, 32, 0, 4. So we get 64 is equal to x minus 2 squared. Now we can square root both sides. Lucky for us, this actually is convenient because the square root of 64 is 8. So x minus 2 is equal to plus or minus 8. We can add 2 to both sides, so you have x equals 2 plus or minus 8, which is either x is equal to 10 or x is equal to 6. Negative 6, my bad. And then the zeros of this function are going to be negative 6 comma 0 and 10, 0. It's just the x-intercepts. You'll need them in coordinate point form. This one, we're going to add 896 to both sides after setting the equation to 0. So 896 is equal to 8x minus 7 squared minus, and then we got rid of that negative 896. We can divide both sides by 8, which leaves us with 896 divided by, 8, 1, 8, 1, 8, 1, 16, 2, which leaves us with 112 is equal to x minus 7 squared. Now we can square root both sides since there's only the square on this side that we can deal with. That leaves us with the square root of 112. Now what we can do is we can separate these. So we know that this is at least divisible by 2. 112 divided by 2 is equal to 5, 1, 2, 6, 56. 56 can be broken down into 7 and 8. 8 can be broken down into 2, 2, and 2. So we've got 2 pairs of 2, which is 2 times 2, which is 4, with a leftover square root of 7. So now we have x minus 7 is equal to plus or minus 4 times the square root of 7. We can add 7 to both sides. And that will give you x is equal to 7 plus 4 square root of 7. And x is equal to 7 minus the 4 square root of 7. And those would be your zeros. And then the x-intercepts. Now this is going to get weird, but it's going to be, so 7 plus 4 times the square root of 7, 0. And then 7 minus 4 times the square root of 7, comma 0. So kind of funky, kind of weird. Now we're going to determine the zeros. F of x equals 4x squared minus 32x plus 48, and state the x-intercepts. I'm going to solve this by completing the square. So these all have a 4 in common. So that leaves me with x squared minus 8 plus 12. And we know that this is probably not going to factor very nicely. We have 12, 3, 4, 2, 6. Oh, actually it might. So negative 2 and negative 6 will make this true. So we'll have 4 times x minus 2 and x minus 6. I just knocked my mic over. And then your answer should be, yeah, so our answers are going to be positive 2 and positive 6. And the intercepts will be 2 comma 0 and 6 comma 0. Determine the zeros of the function h of x equals x minus 4 squared plus 50. What we can do is we can move this over. So, sorry, I forgot to mention, I was setting this up to do completing the square, but sometimes that's not necessary. Sometimes you can do the easier factoring. So, yeah, anyway, moving on. we have, we're going to minus 50 from both sides. And, well, we're going to set this equal to 0 first. So we have negative 50 is equal to x minus 4 squared. We can square root both sides. And that will give us an error if you plug this into your calculator. Because you cannot have a negative inside a radical with an even square root. Because no combination of numbers, no number times itself in an even interval, so like no number times itself twice or 4 times, will ever give you a negative number. So what happens is we actually have to take out an I. So, but first let's prime factor it. So we have 5 and 10 and 5 and 2. So we can take out a 5. So we'll have 5 square root of 2 left over. But we also have to take out an I to get rid of that negative on the inside. It's kind of weird, but you'll get used to it. Is equal to x minus 4. We can add 4. Oh, and this is going to be plus or minus, by the way. So we'll get 4 plus or minus 5i square root of 2. Yeah, kind of a weird concept. Yeah, so that would be your 0. Your 4 plus 5i times the square root of 2, and your 4 minus 5i times the square root of 2. Yeah, kind of weird, kind of wonky, but you'll get used to it. Use a quadratic formula to determine the zeros of the function. 25x squared minus 40x plus 65. So when we're using the quadratic formula, there are a few things that we can do. We can take out a greatest common factor. So this has 5 in common. So we'll do 5, which leaves us with 5x squared minus 8x plus 13. And what we can do now, now this is going to be looking really crazy, but you're going to understand soon enough, and you'll memorize this probably. It's the best practice to memorize it. Minus 4 times a times c divided by 2a. Okay, there's a song to remember the quadratic formula. I'm not going to sing it. I honestly had only heard of it like a couple weeks ago. People had mentioned it but never sang it to me, and I probably will mess up the beat. But basically, it's negative b plus or minus the square root of 4 squared minus 4ac, all divided by 2a. There's a way to get here algebraically through completing the square, but we aren't going to do that today because that is a lot of work, and will add a lot of padding to this video, which is not desirable. So, you just got to take me for granted. You probably want to memorize this formula. You are able to complete the square by, you are able to factor and find the zeros by completing the square. However, with something like this, it wouldn't really make the most sense because you'd have to take out another 5, and that would leave you with fractions, and no one wants to deal with fractions. So, what we can do now is, if you remember our standard form, not standard vertex form, but standard form, it's ax squared plus bx plus c. We're going to take our b, which in this case is negative 8, and we'll just plug in. So this is our b, this is our c, and this is our a. So we'll take our negative b, which is negative 8, plus or minus the square root of negative 8 squared, minus 4 times 5 times 13, all divided by 2 times 5. Now, that's really gross, huh? But we can just take this one step at a time. So this is, this is going to turn into positive 8 plus or minus 64 minus 20 times 13. 20 times 13, 260. Yes, and then all of that divided by 10. And that will give you 8 plus or minus, what is 260 minus 64? 6, 3, 1. You get 136 in there. Divide by 10 still. We can take stuff out of this for sure. So we'll do 136 divided by 2. which is 6, 1, 6, 8. 68. And then that can be divided into 2. 68. Whoops. Which is 3. 34. Which can be broken down into 2 and 17. And 17 is prime. We have 2 2's that we can take from this, and then a 2 left over. So 17 times 2 is, 34. So we'll have a 34. Oh, and by the way, this is negative. We'll have a negative 34, but now it's positive because we're taking out an I, and also a 2. So 2I. 8 plus or minus 2I, all divided by 10. And then what we can do from here is we can sort of like simplify a little bit more. So we have 8 and 10 both go, 2 goes into both of those. So we're going to have a 4 over 5 plus or minus, and then 2 goes into 2 and 10, which is going to be, so plus or minus 1 over 5. Since they share denominators, we can just combine them. So 4 plus or minus I, this I stays, over 5 times 34. Square root of 34. Yeah, so it's kind of a mouthful, kind of a lot. Those would be your zeros. It's really gross, but that is the quadratic formula. We're going to have to live with it. You're going to be seeing this quite a bit. Please memorize that formula. I don't know where I put it, right here. Please memorize this formula. It will save you in a lot of situations. So have a good one.